Hello everyone, my name is Sumit Gupta and today I'm gonna talk about AWS Storage Gateway as part of my final project. The problem description for my project is there is a company ABC which use MySQL database to store all their data for their online applications. The problem which they are facing here is that they just have only one data center, and in case of disaster they don't have any backup locations. So to maintain business continuity here, AWS Storage Gateway Service is used to store all their backup files on cloud. And so AWS Storage Gateway Service connects on-premise appliances with cloud-based storage. We can configure AWS storage in three ways. The first one is gateway cached volumes. So using this service primary data is stored on S3, and only the frequently accessed data is stored locally. This is so for the better performance. There will be low latency if the data is stored on premise. It reduces your primary storage cost dramatically. The second configuration is gateway stored volumes. So in case low latency data is required for majority of your data, we go with this option, wherein your backup data just get asynchronously backed up to Amazon S3. And this service could also be used to reduce storage cost and in case of disaster recovery and to maintain business continuity. The third configuration is gateway virtual tape library. We can call it gateway VTL. So this service is used to store the data for which the retention periods are really high. So what happens in this service is that you store your less access data to virtual tape, which is backed by S3 or AWS Glacier. The virtual tape library exposes an industry standard iSCSI interface, which provides a backup application with online access to the virtual tapes. So this is a really good way to save cost on the data, which is very less accessed, and it is just used for retention period. So what are the benefits of AWS Storage Gateway? Your data is secured since it is stored and protected using AES 256-bit encryption. It's cost effective. You reduce cost on your on-premise storage. Maintenance is really easy, and in case you need a lot of storage, the scaling is very simple on AWS S3. Your data is durable. Here durability means that S3 stores data redundantly at multiple facilities. So even if one of the facilities your data gets corrupted, you don't need to worry. The data is still present in the other locations. We can very easily configure this whole setup. AWS Gateway Storage Service can be configured very easily. It is very easy to integrate with other Amazon AWS services like EC2, EBS, and last but not the least, that it just takes incremental backups. So once you have loaded all your data, only the changed data gets uploaded, thereby reducing the network usage. So this is a high level overview of how we configure AWS Gateway Storage. So in this diagram we can see this, by the way, this diagram has been taken from aws.amazon.com. So we see this is the company ABC data center, and this is Amazon S3. So to activate this service, you need a host in your data center. So we can see this is the host, and the gateway, Amazon Gateway, could be downloaded as a VM from the Amazon management console, and this VM could be started in the host, and using and in this VM we create some volumes which could be mounted as iSCSI devices on your application servers. So whenever we store any data on these iSCSI devices, those gets asynchronously backed up to Amazon S3. So what are the other use cases for this particular service? So this could be used for backup. the Amazon S3 service, Amazon storage gateway service is really reliable, it is secure, and it is very cost effective as well in few of the cases. It could be used for high availability, disaster recovery, business continuity. Like in my case, since company ABC has just one data center, I can store all my backup files there, and in case of a disaster, start a EC2 instance and restore my database backup file, and my database would be up and running. So it could be used for compliance purposes. Virtual tape could be used to store data which requires long-term retention. Then the last use case is file sharing. So as I already mentioned in my previous diagram, that the volumes are mounted as iSCSI devices, and these iSCSI devices appears like a local drives which could be shared across the company. So what were the drawbacks and challenges which I noticed during the course of my project is that though the storage cost is less, we still need to pay for the VMware hypervisor ESXi host. The other thing is network bandwidth. So when we are uploading all our data to S3, it is gonna consume a lot of our network. And other than that, one thing which I noticed was that it doesn't replace our local storage at all. So if I have to store some data on AWS gateway storage, I need to have a volume on my premise as well. It supports only iSCSI. There's no NAS or NFS support for gateway, and iSCSI gateway supports only up to 1 terabyte volume. So if you have data more than 1 terabyte, we need to create multiple gateways. So these are the high level instructions which I followed in my demo. So in my demo, what I am doing is that I am taking a backup of my MySQL database which is running on my laptop, putting it on the iSCSI volume which is mounted, and this volume gets backed up on S3. There I create a snapshot, and from that snapshot I create a volume, then attach that volume to an EC2 running EC2 instance. So I will go through these steps in detail here. So the first step which we need to follow is, since I did all my project on my laptop, we need to download VMware Workstation. For my project, I downloaded Workstation 10, install it. Then for the host, as I mentioned that we need a host for this to configure Amazon Web Service Gateway Storage Service. So here I used VMware ESXi server. We can also use the Microsoft hypervisor. So download VMware ESXi server for the host from the VMware website. Then install the ESXi server. So when we are installing ESXi server, after that we need to install that host on our workstation. So we need to make sure that the server on where we are installing this ESXi hypervisor has minimum of 4 virtual processors, minimum of 8 GB RAM, and 75 GB of disk space. Actually, for my project I used a less amount of disk space, but in a real world scenario we will need actually a very large amount of disk, because these disks are used for our buffer and the volumes. So during creation of this virtual machine, we need to use bridge networking, then SCSI disk type, and once this is done, we'll power on the ESXi server so that the installation takes place. So we can see in this slide that installation has already taken place. One thing to notice here is that it does take some time for the installation to finish, and after that we can configure IP address. We can configure static IP address by going through the settings of this virtual machine. We can also enable SSH and SCP for this virtual machine by going through the settings. So we see here the IP address of this machine got allocated once it was powered on. And so let's go to our next step. So for this particular service, we need to do a to and fro, like a lot with Amazon AWS Management Console, as well as going back to what we have to do on our laptop. So now, earlier in my previous slide, I was on my doing all this work on my laptop. Now in this slide, we have to go back to Amazon Management Console and select services, storage gateway service, and create a new gateway. While creating a new gateway, in this step we have to download the gateway virtual machine. Once you have downloaded the gateway virtual machine, we can just enter continue to go to the next page. Now once you have downloaded, we need to connect to that. In the previous slide, I showed you that we got an IP address for the host. Now let's connect to this host using VMware client. Once we have connected to this host, it looks like this. You can see that same IP address here. Now we need to deploy the OVF template using this VMware client on this host. And this OVF template is the same file which we downloaded here from AWS Management Console while creating new gateway. Once the file is deployed, we need to edit this virtual machine settings. This virtual machine is the storage gateway machine. Actually, we need to add few disks for storage and buffer, and SCSI controller type, and set the SCSI controller type to para virtualization. After editing all these settings, we need to power on the VM, and once we have got the powered on the VM, we will get an IP address of this virtual machine. This is the IP address. Here we can see is our virtual machine. Now go back again to the AWS Management Console, enter the IP address of the gateway virtual machine which we saw in our previous slide. Here it is. After entering the IP address, we need to activate this gateway. Once the gateway is activated, it will lead us to this following page, and in this following page we need to create new volumes. And here, while creating volumes, we will choose the same disks which we created while creating the gateway virtual machine. After creation of the volume, we will start the iSCSI initiator on the Windows, and we will connect to our volume. Once we are connected to the volume, now we can map that volume using disk management tool on my laptop. So this is how it looks like. We can see it's a 3 GB capacity volume. It got mounted as E drive on my laptop as a 3 GB capacity volume. So now comes the part wherein I will run my database backup script, which will take the backup of my database from my local MySQL database and store it on the volume which we mounted just in our previous slide. So once it is done, it has backed up and stored that backup file on E drive. It gets backed up on S3 asynchronously. We need to confirm that. So what we do that, we can do that using AWS console. We will create a snapshot of that volume, and we can again create a volume using that snapshot as well and mount it back to my laptop. But in my case, I'll test it differently. We will launch an EC2 instance which has MySQL on it, create a volume from the snapshot, and attach that volume to this EC2 instance. Once we have attached it, we will mount this volume on the EC2 server. Once we have done that, we need to install MySQL on EC2 instance, start the service, and using that backup file, here is, after mounting it, I can see it will go there. We can see our CD backup, and these are the two backup files of my database. So we will use this database backup file to restore the database from using these backup files. So we will run this command to restore the database from the backup file. and log into MySQL on EC2, and we can see our database contents there. So we see how easy it was to configure the whole service, AWS Gateway Storage Service, and it is really simple to use this service for disaster recovery. So in my project, company ABC wasn't having any backup location, but it was very easy to configure this service and store all our backup files on Amazon S3, and those backup files could be used in EC2 instances, and your database could be running in hardly any time. So the learnings were that we can easily configure it even during disaster recovery. We can go back in launch multiple EC2 instances and restore our backup files there, and our database would start running with just few clicks. Then we have different configuration options available. There was one thing which I encountered while going through my project is if the host is not configured with minimum specification, the gateway does not work. So it fails to start actually if I don't specify minimum of 4 CPUs and 8 GB of RAM. So that was all as part of my final project. Thank you.